All right, 2.8, day 2. Let's look at number 14. When you're looking at 14, it says, if this is your fuel economy in miles per gallon, and this is your velocity in miles per hour, then what is the meaning of F prime of V? Well, one way to think of that is it's the change in F over the change in V. So this is the change in fuel economy divided by the change in velocity. So I guess F prime of V is the instantaneous rate of change of fuel economy with respect to velocity. Sketch a graph. We'll find to sketch a graph. It looks like if we're going for a horizontal tangent line, excuse me, maybe it's about here at 55 degrees. Then if I go a little bit to the right, it looks like it's a little negative. And then here it's a little more negative, a little more negative. So in other words, what that's really saying is that our change, a little negative, a little more negative, a little more negative. Make sure that that's kind of what I was thinking. What's really telling us is that here, the change in fuel economy with respect to velocity is 0. So if you go any faster, it's not really helping you. But if you go just a little bit faster, we get negative numbers. And so that means your fuel economy is going down as velocity goes up. So over here, what we're saying is that the fuel economy, the change in fuel economy with respect to velocity is negative over here. But then it looks like I have a really small positive, really small positive, really small positive tangent line over here. Then it looks like it gets more positive, and it kind of stays constant. More positive, and it kind of stays constant. So it looks something maybe like this. But the main thing to notice is that over here, the change in fuel economy with respect to velocity is positive. So if you go for every little bit you increase velocity, you actually get a positive change in fuel economy. Over here, for a change in velocity, you get a negative change in fuel economy. So then C asks, what does C ask? C asks, at what speed should you drive if you want to save on gas? Looks like you should drive 55 miles per hour, comma, where F has a maximum, where F it is its largest. So it's not going up the hill and it's not going down the hill. It's at a maximum right here. So notice if our derivative or our change is positive, it stops for a second, then becomes negative. That is where we have a maximum. And we're going to talk more about that later. So this question really just wants you to start thinking about how the derivative and the function itself kind of relate to each other. Okay. Oh, poop. So let me make sure that's really clear that this is my function df dv down here. All right. So that's my part B. So if I did 14, now I need to do 22. So what does 22 ask? It says, look, 22, give me just 1 second. I was on the wrong section. So if I look at 22, it's going to ask me to find a derivative using the limit definition. So 22 says that your function is mx plus b, so the derivative is just f of x plus a little bit minus f of x all over that little bit. But to make it the derivative, we have to introduce the limit. So that's what our derivative would be. So over here on my scratch paper, I find out what f of x plus a little bit turns out to be. It's just going to be my mx plus b, but what I plug in for x is just this x plus h. So now if I distribute, I get mx plus mh plus b. So I have the limit as h goes to 0 of mx plus mh plus b minus what's in here, which is just this, all over my h. Why is that great? Because I think it's clear that these cancel out nicely, this one and these cancel out nicely, to where you're only left with the limit as h goes to 0 of mh over h. Why is that great? Because my h's cancel out, and I want to know as h goes to 0, what happens to m? Well, it's just m. So my derivative is always equal to m. Why is that true? Because this is a line. It's a line with a slope m. So the small mini tangent line is always equal to m. No matter what you do on the line, y is equal to mx plus b. So the slope of the tangent line is just the derivative. That's why the derivative of my function is a constant m, because it's the line. So now I do 26. Okay, so wait, it says state the domain of the function and its derivative. Well, the domain of f is all reals, and the domain of f prime is also all reals. You can put in anything you want. Okay, let's get 26. I get this thing, which is 1 over root t. And they want to find the derivative. So that's going to be the limit as h goes to 0 of g of t plus h minus g of t all over h. So over here on my scratch work, g of t plus h is equal to 1 over the square root of t plus h. So I just replace the input with what I've plugged into the function. Okay. So this is the limit as h goes to 0 of 1 over the square root of t plus h minus 1 over the square root of t over h. So we see that the derivative is just simply a limit. And what do we always try first with a limit at a point? Well, we try and plug in. I think it's clear you get 0 over 0, so I need to change the form. And I do that here by multiplying by the square root of t on top and bottom to get rid of this fraction. And I multiply by the square root of t plus h on top and bottom to get rid of this fraction. So when I distribute very carefully, I think that you will see that all of this hits that and just gives me the square root of t. All of this hits that and just gives me minus the square root of t plus h. But it's all over root t plus h. Okay, so I've got this new thing which I'm trying to do. Let's see. Let me make sure that that's right. This hits that and gives me this. Let me make sure that's right. This hits that and gives me this. This is that. Oh, I forgot my h. Okay. That h is oh so important. So now again, I have a new limit. So we just used a well-chosen one. That was a good choice. But now I think you'll see that it's still, hey, what's up? 0 over 0. So I'm going to have to use another well-chosen one. In this case, we're going to use the conjugate. And the reason is because I just want to change the form, and I know that that's often something I do with square roots. So when you multiply it all out, I think you can see on top you're going to get t minus t plus h. These parentheses are so important. On the bottom, you're going to get h, what? Root t plus h times root t plus h. That is not easy. So let's see what we end up getting. So now I take the limit as h goes to 0, and these cancel out nicely. I'm left with a negative h on top and an h root t plus h times root t plus h. These cancel out. I get the limit as h goes to 0 of negative 1 over root t plus h times root t plus h. So now we're ready to see what happens. Okay, if I let h go to 0, so I'm going to go ahead and copy this just to be careful. Copy. I'm going to go this way. And so if I let h go to 0, is it clear that I should get negative 1 root t times root t plus root t? Okay, so what is that going to give me? That's going to give me negative 1 t times 2 root t, right? What does that really mean? That gives me negative 1 t times 2 times t to the 1/2. But what do you do when you have like bases and you're multiplying them together? You add the exponents. So this is really negative 1 over 2, and then 2 to the, well, this times this is this to the this plus that. So it's 2 to t to the 3/2. So that is exactly what you should get. Cool. So just to be careful, let's go back and look at our original. It asked what was the domain of this thing. I think you can see that t needs to be greater than or equal to 0 because of square root of a negative, right? But we also, because we have stuff over 0, I think it should be clear that t cannot be equal to 0. So the domain for this thing is going to be 0 to infinity. If we come over here, I think it is going to be the same exact thing. The domain of this f prime is going to be 0 to infinity for the same reason. If you say square root of a negative is bad, this thing down here is really just t cubed, the square root of that. And so that means that t is going to have to be greater than or equal to 0. And then if you don't want stuff over 0, I think it's pretty clear that t is not going to be equal to 0. So when you put those together, that's where you get this. All right, and I'm going to stop there, and we'll do more in class. Peace out. Or actually, I'll do the rest of the homework in the next video.